Now let's just move on further towards the question number 3rd, which says the very first part, which says that prove the following identities where the angles involved are an acute angle. So here we are taking the angle as nothing but theta. So theta is actually an acute angle over here, and we just have to prove that LHS is nothing but is equal to the RHS. So let's just start with the very first part. Let us suppose if I'm just taking this one as LHS and I'm just taking this one as nothing but RHS, and from the LHS I'm just moving toward the RHS. So the LHS actually says it is cosecant theta minus cot theta's whole square. So as you can see, we have the RHS into the formation of cos, and it means that we have to reduce this particular formation into the formation of cos. So let us suppose if I'm just converting cosecant theta into the formation of sine and cot into the formation of sine and cos. So let's just start the conversion. We can write cosecant theta as nothing but 1 by sine theta minus of cot theta can be written as cos theta divided by sine theta whole square. Since we know about this particular fact that cosecant theta is nothing but the reciprocal of 1 by sine theta, and cot theta is nothing but is equal to cos theta divided by sine theta. So hence using this particular fact, we can write this as 1 minus cos theta whole square divided by sine theta whole square. We can definitely write this particular form. And now let us suppose if I'm just writing it as 1 minus cos theta's whole square divided by sine theta whole square can also be written as sine square theta. Now we know about a particular fact that sine square theta plus cos square theta is actually nothing but is equal to 1. We definitely knew about this particular fact. So since we are using the fact that sine square theta plus cos square theta is actually is equal to 1, we can find out the value of sine square theta from here, which is nothing but 1 minus cos square theta. So using this particular identity in this particular equation, let us suppose if I'm just taking this as 1, I'm just taking this as 2. So we can write it as from 1 and 2, we can write this as nothing but 1 minus cos theta whole square divided by 1 minus cos square theta. Now again you can see we can write 1 as nothing but 1 square, and we can again use the algebraic identity in the denominator as 1 minus cos theta whole square divided by, this can be a square minus b square, which is nothing but is equal to a minus b into a plus b. So using this particular fact, we can write 1 minus cos square theta as 1 minus cos theta into 1 plus cos theta. Now again you can see over here that in the numerator and in the denominator we have 1 minus cos theta. So if I'll cancel this 1 minus cos theta with 1 minus cos theta, the only value will remain as 1. So hence it implies that this is 1 minus cos theta divided by 1 plus cos theta. So hence it is the value that we are getting as the right hand side. 1 minus cos theta divided by 1 plus cos theta is just same as that of RHS. So hence at the end we have concluded LHS is nothing but is equal to the RHS. Hence proved this particular part. So this is all about the very first part in which we have proved LHS is nothing but is equal to the RHS. Now let's just move on further towards the second part of the question number 3rd, which says again we have to prove LHS is nothing but is equal to the RHS. So let's just start the proof. We are just taking LHS as nothing but cos of A minus of sine of A plus of 1 divided by we have cos of A plus of sine of A minus of 1, and we just have to prove it that this is actually nothing but is equal to the cosec of A plus of cot of A. It means we have to reduce this particular LHS into the formation of cosec and cot. So if we are just talking about cot, so we know that cot is actually nothing but a ratio of cos by sine. So it means we just wanted to find out or we have to convert this into the formation of cos by sine. So let us suppose if I'm just dividing sine in the numerator as well as in the denominator. So dividing sine A in numerator and denominator as well, and just I'm splitting the sine A in this manner. Cos A by sine A minus sine A by sine A plus 1 by sine A. We can write them in this manner, particularly, and thus we can write it as cos A by sin A plus of sin of A divided by sin of A. Further, we can write this as minus 1 by sin of A. Now again we can see cos by sin is actually nothing but cot of A minus of 1, because these values get cancelled with each other, plus 1 by sin of A is nothing but cosec of A. So this is cosec of A divided by, this would be cot of A plus of 1 minus of cosec of A. So we can write this particular P by Q formation, that is LHS, into this form. So let us suppose if I'll rearrange them. If I'll rearrange them, then we can write it as cot A plus of cosec of A minus of 1 divided by cot of A minus of cosec of A plus of 1. So let us suppose if I'll write the reason why I am writing cot of A as nothing but is equal to cos of A by sin of A, since we know that this is nothing but is equal to this, and further 1 by sin of A is nothing but is equal to cosec of A. So this is my reason that why I am writing this P by Q formation into this one. Now let's just move on further. Since we wanted to find out only one thing, that is it is equal to cosec A plus cot A, so we have to remove this P by Q formation over here. So let us suppose if I'm just using this one, how we are using this one. So let us suppose if I'll write this particular formation as cot A plus cosec A minus of cosec square A minus cot square A. Let us suppose if in place of 1 I'm just writing this particular identity. Why I am writing this identity? Because we know that since we know that 1 plus cot square A is nothing but is equal to cosec square A, so we can write 1 as nothing but cosec square A minus of cot square A. So using this particular factor, I am just writing 1 as cosec square A minus of cot square A. Now again we can write this particular formation as cot of A plus of cosec of A minus of, we can use the algebraic identity over here. This would be cosec of A minus of cot of A and cosec of A plus of cot of A, using the algebraic identity A square minus B square whole divided by cot of A minus of cosec of A plus 1. The denominator will remain as it is. Now you can see we can take this value common out of it. So cot of A plus of cosec of A is common. So we are getting 1 minus of cosec of A minus of cot of A as the value which is remaining under the bracket. And further we have cot of A minus of cosec of A plus of 1. So let's just sort it out. This is nothing but cot of A plus of cosec of A, 1 minus cosec of A plus of cot of A whole divided by, we have cot of A minus cosec of A plus of 1. So you can see all by yourself that at the end we are getting the value in this particular formation such that this value and this value are getting cancelled with each other, and at the end we are getting cot of A plus of cosec of A, which is nothing but actually is equal to the RHS, which is actually is equal to the RHS. So hence at the end we have proved LHS is nothing but is equal to the RHS, which is proved using the trigonometric identities and various other concepts. Now let's just see the next part of the question, and the third part says that cosec A minus of sin A into sec of A minus cos of A is equal to 1 by tan of A plus cot of A. So we just have to prove this fact. So let us suppose if I'm just starting with the LHS. So my LHS is actually nothing but cosec of A minus of sin of A into sec of A minus of cos of A. So let us suppose if I'm just solving the LHS, and I will try to reduce it into the formation of RHS. But as you can see in the RHS we have tan A and cot A. So it would be a difficult task for us to convert cosec and sin or sec and cos into the formation of tan and cot. It means we have to solve both the sides in order to prove LHS is nothing but coming out to be equal to the RHS. So let us suppose if I'll just solve LHS first. So we know that 1 by cos cosec of A is written as 1 by sine of A minus of sine of A. Further, we know about sec of A. This is nothing but 1 by cos of A minus of cos of A. Let's just sort it out. Let's just take the LCM of this one. So this would be nothing but 1 minus sine square A divided by sine of A into 1 minus cos square A divided by cos of A. Again, we can use the concept over here that we know that sine square A plus cos square A is nothing but is equal to 1. So we can write 1 minus sine square A as nothing but cos square A, and we can write 1 minus cos square A as nothing but is equal to sine square A using this one single trigonometric identity. So hence, using this particular conversions, we can write 1 minus sine square A as cos square A divided by sine of A, and further into this would be nothing but a sine square A divided by cos square A. So cos A and 1 cos A get cancelled, sine A, 1 sine A get cancelled. So we are getting at the end the value sine A into cos A is the value of LHS. Now let's just sort the RHS side. So since you can see for the RHS we have 1 by tan A plus cot A. So let's just convert tan A and cot A. So since we know that tan A can be written as sine A by cos A plus cot A can be written as cos A by sine A. Let's just take the LCM over here. So this can be written as 1 by sine square A plus cos square A divided by sine A into cos A. This value will be converted into the numerator, and thus we can write this as nothing but sine A into cos A divided by sine square A plus cos square A. Again, we know that this is nothing but the trigonometric identity that we have, which is nothing but 1, since sine square A plus cos square A is nothing but is equal to 1. So hence at the end we are getting the answer as nothing but sine A into cos A, which is nothing but is equal to RHS. Now you can see all by yourself that LHS is actually coming out to be is equal to the RHS. So hence at the end we can say LHS is nothing but is equal to the RHS. So hence proved that the left hand side is actually nothing but is equal to the right hand side using the concept of the algebraic identity. So with the algebraic identity, this is nothing but the end of our chapter, which is nothing but called as the introduction to trigonometry. I hope all the concepts that we did in the introduction to trigonometry chapter means the definition of the trigonometry, that how it actually is useful in our real life, how we can relate them with our real life, and thus after talking about the very first concept of trigonometric ratios, then we have talked about the complementary angles, then we have talked about the identities. I hope all these concepts are all clear to you. Now let's practice more and more questions all by yourself of the chapter Introduction to Trigonometry.